Hey, here we are, trig day number 4. Looks like a nice little walk through the park, some trig solving, trig formula list, and identity proofs. Let's do it. Alright, by memory, put these down, so take a moment, make sure and account for both symbols, and we'll see how you did. Alright, hopefully you got these all right. Notice that we got plus, goes with plus when we've got sine of a plus b. Sine of a minus b has a minus between. Cosine a plus b has a minus. Cosine of a minus b has a plus. Tangent of a plus b has a plus on the top, minus on the bottom. Tan of a minus b has a minus on top and a plus on the bottom. Coordinate those. Those, I believe, we'll have to check the IB formula sheet, but I think those need to be memorized, I think. Let's move on. Alright, let's see what you remember here. Don't be afraid of the lightsaber there. Alright, we just did these. Let's scratch these for right now. Just did them on the previous page. Okay, see by memory what you remember here. Alright, all the way down the double angle formulas, there's 3 for cosine of 2 alpha. Tangent of 2 alpha, as you see here. Our 3 Pythagorean identities: sine squared plus cosine squared equals 1, 1 minus sine squared equals cosine squared, 1 minus cosine squared equals sine squared. Here's where you might have had something a little bit different. If you put like opposite over hypotenuse for sine and hypotenuse over opposite for cosecant, I wouldn't blame you there. But technically these are all, the 2 in black, the 2 in red, the 2 in blue are reciprocals of each other. So I wouldn't get hung up on whether or not you put opposite over hypotenuse or 1 over cosecant or whatever. But technically these are the definitions of each of those. Let's move on. Yeah. Alright, let's see what you remember here. Take a moment, write them down. Okay, so let's start up here in the top right. These are even-odd identities. Sine and tangent are both odd functions, therefore sine of negative a is equal to negative sine of a. Same thing for tan negative a. But cosine is even, so it retains a positive value, so those two would be equal, right? Over here, sine and cosine of pi over 2 minus b would just be the other function of that angle b, right? So we talked about that a few slides back, maybe even last lesson, I don't remember. Cosecant and secant are going to do the same thing as sine and cosine. And then what's cool is, so these are kind of paired, sine and cosine, cosecant and secant, so are tangent and cotangent. So tangent of pi over 2 minus b would be the cotangent of b, and cotangent of pi over 2 minus b would be the tangent of b. Alright, now over here, these are called half-angle identities. Half angles. I'm not going to write out the word, but I'll just put half theta. Right? So half-angle identities are formed directly from the following. So cosine of 2 alpha is equal to 2 cosine squared alpha minus 1. Alright, so let's just say for a moment this was just alpha. Right, so if that was a 2 alpha and this is an alpha, then if I change that to an alpha, this would be alpha over 2. So let's solve for cosine of alpha over 2. What would I do? I'd add 1. Right, so I'd have cosine of alpha plus 1 equals 2 cosine squared alpha over 2. Alright, if I kept going, I'd divide by 2, so it'd be cosine of alpha plus 1 over 2 equals cosine squared alpha over 2. I keep going. Then what I do next is square root. And now we have the cosine of alpha over 2. So that would be the cosine of alpha over 2. It'd be the square root of cosine of alpha plus 1 over 2. Okay, in a similar fashion, which I'm not going to go ahead and do on camera, but this might be a little counterintuitive, because you'd think sine of alpha over 2 would have something to do with sine function, but it doesn't. It's actually 1 minus cosine of alpha divided by 2. Alright, and tangent of alpha over 2 actually comes out to be 1 minus cosine of alpha over sine of alpha. I wouldn't memorize those. Those will be given to you in your IB packet, so just be familiar. Alright, so a bulk of today's lesson is proving identities. Alright, so what I want to do is run through a few of these. These are some practice problems that you'll be doing in class, but I'd like to run through them. We'll start here with 15a. Alright, so what I would do here is I would probably identify anything that I see that's an identity. Alright, so I see an identity in the numerator here. I'm going to take the complicated side, show it equals 0. So that would be 2 sine theta cosine theta. Denominator is technically 1 plus, and I'm going to write this as 2 cosine squared theta minus 1. I'm going to write tangents as sine of theta over cosine of theta. So I see first of all that these two ones will cancel. I also see that one of the cosines in cosine squared will cancel with the cosine in the numerator. And then the 2's will cancel here and here. So I get sine of theta over cosine of theta minus, sine of theta over cosine of theta. And that equals 0. So I've shown that the left side equals the right side. Signature. Okay, in part C, more complicated side would be the left side. I'm going to use identities here. Sine of 2 theta is 2 sine theta cosine theta over sine theta. I think you can see what's going to happen here. Get cancellation. Boom, boom. So I'm going to have 2 cosine of theta minus, let's use a little identity work here. Let's see here, cosine of 2 theta, I'm going to go with 2 cosine of theta squared minus 1 over cosine theta. Alright, now what I'm going to do is I'm going to split that up. I'm going to go 2 cosine squared theta over cosine theta. I'm allowed to do that because there's only one term in the denominator. Minus 1 over cosine theta. Alright, so I see that cosine squared will become cosine, that'll cancel there. So I got 2 cosine theta minus, looks like 2 cosine theta minus, and 1 over cosine theta is secant theta. So when I simplify, distribute the negative, that cancels these two, but that negative also distributes there and makes that a positive secant theta, which is what we're looking for. Sign it. Simplify, oh gosh. Okay, so what I would do here is I would identify that this is a tangent, either a tangent of some angle, 80, either plus or minus 20. So consult tangent of A minus B equaled tan A minus tan B over 1 minus tan A tan B. Okay, you get the picture, right? Or 1 plus, I'm sorry, 1 plus. So identifying this minus and this plus will tell us what we want in between here, which is minus. So technically this simplifies to tangent of 60, which if we could solve the old unit circle, right, I get 1/2 root 3 over 2. Tangent is y over x, so root 3 over 2 over 1/2 is going to be root 3. So this will reduce to square root of 3. Alright, so if tan A plus B is 3/5 and tan B is 2/3, find the exact value of tan A. So let's write out tan A plus B. Tangent of A plus B will equal the tangent of A plus the tangent of B over 1 minus tan A tan B. What do we know? Okay, so we know that the tangent A plus B equals 3/5. So I know this is 3/5. I know the tangent of B is 2/3, so I don't know the tangent of A. I don't know the tangent of A, but I do know the tangent of B, 2/3. 1 minus tan A, still unknown, times 2/3. Okay, so let's do some work from here. We need to isolate the tangent of A. So I would probably, oh boy, cross multiply. So if I do that, I get 3 times 1 minus tan A times 2/3 is equal to 5 times the quantity tangent of A plus 2/3. Let's distribute. I get 3 minus 2 tan A is equal to 5 tan A plus 10/3. So it looks to me like, let's change 3 to 9/3. So it looks to me like if I subtracted 10/3 from both sides and added 2 tan to both sides, oops, I would get myself 7 tan A equal to negative 1/3. So let's divide both sides by 7. I think I'm getting that. There we go. Alright, that's it for Trig Day 4. See you next time. Have a great day. Alright, so solving trig equations must be true for specified values of theta. Solve for trig function or theta only. Work both sides at the same time like solving any equation. Alright, find for sine 2 theta, okay, where cosecant squared plus secant squared equals pi.